Hey guys, this will be just a short video on how you add and subtract matrices and then also something called scalar multiplication as well. So this is a very simple operation. Hopefully you found the order and the element part of matrices pretty easy so far as well. This I promise will not be terribly difficult. So when you add or subtract matrices, basically you're just going to match up the corresponding elements. So for example, this one says b plus a. Well, matrix B right here, matrix A right here. We're just going to basically match up all of the corresponding ones. So like this one and this one go together, right? Because they're both in row 1, column 1. This one and this one go together because they're in row 1, column 2. This one and this one go together because they're in row 1, column 3, so on and so forth. You just match them all up and you just add individually the elements. So with matrix addition, subtraction, the way that I would say it is you just add or subtract you can say the matching or the corresponding elements. We'll say the matching elements in each position. And really that's all there is to it. Now there's just one thing you have to make sure that's true is when you add and subtract matrices, they have to have the same dimensions. So these must have the same dimensions. And your answer will be a matrix with the same dimensions. Must have the same dimensions. Delta math, I don't think will give you any that don't have the same dimensions, so all of these should be doable. And the next activity, I believe there's some that you will get undefined. But for this, I think they're all doable because they're all going to have the same dimensions. So then our answer is going to be a matrix with the same dimensions as well. So if we look at this, we've got two 3x3 matrices, right? So then our answer, which I'm going to go ahead and just do first, add a row and add a column to this to make our answer also a 3x3 matrix. So then when we add b plus a, the order isn't really important for addition, but for the sake of doing it right, I'll go ahead and write it here. We're going to do this one plus this one. So it's like 1 plus -1 in that first entry. So row 1, column 1. Our next entry is going to be, well, 0 plus -2. And then we've got -3 plus 3. So that's our first row. The next row, we've got -5 and -1. So -5 plus -1. 3 plus -5. And -4 plus -3. Obviously, you can probably do these in your head. That's fine if you're doing it in your head. You don't have to write out all of this stuff because this is a pretty easy operation. Just be aware that if you do mess up just a single element, then you will get the entire thing wrong. You do have 2 chances, but try to do your math correctly there. So we're going to get 0, -2, 0. We'll have -6, -2, and actually, as I was saying that, I was talking, I wrote the wrong number. This should be -3. It's -4 plus -3. It's -7. And then we've got 0, 1, and 2. So I'm just going to go ahead and type those in. Hopefully I did it all correctly. If not, then just go through and double check, and you probably just missed one of them. Submit. Okay. So very simple. We'll go ahead and just do one more. So again, these are 1x3 matrices because they're both 1 row, 3 columns. This is a minus b, so just be careful with the minus. I'm gonna go ahead and actually get the right dimensions here first. We only want 1 row, so we're gonna subtract, and we want 3 columns. And then we're gonna do a minus b, so we just match them up, this one and this one. 5 minus 2 in our first one, and then we've got 4 minus 2. And then we've got 2 minus 3. and just do those computations. Should end up with 3, 2, and -1. And again, feel free to do that without writing it out. You guys are in pre-calculus, so hopefully you can add positive and negative integers. All right, so let's go ahead and look at the little bit harder ones. This is scalar addition and scalar multiplication. All right, now the reason it doesn't just say multiplication is because multiplication is a bit harder, and we'll get to that possibly in the next video. But scalar multiplication is easier. Scalar multiplication, what I want you to think of here is kind of just like the distributive property. So scalar just means a single number. I didn't mean to do that, sorry. Distributive property. A scalar is just a single number. So in matrix multiplication, you're going to multiply a matrix times a matrix, but in scalar multiplication, you do a number times each element in the matrix. And again, this is not a very difficult thing. We're just going to do a number times each element in the matrix. Sorry. Okay, so what I mean by that is this actually has a few operations in it, this first one. 1/3 b minus 2a. It has two scalars times two matrices, and then we also have the subtraction. So what it would look like would be 1/3. I'm going to write out this matrix B, -15, 6 and 3, 0, 27 and 3. You may want to actually write these out, recopy it on a piece of paper, and then -2, parenthesis, or actually our matrix bracket, -5, -6, -3, 6, 0, 3. All right, so the reason I said think about the distributive property is essentially what happens with the scalar multiplication is you have to distribute this 1/3 into all of the elements. We're going to multiply all of these elements by 1/3. So when we do so, we're going to have 1/3 times -15. It's really the same thing as just dividing by 3. So that's -5, 0, so 1/3 times 0 is 0. 1/3 times 6 is 2. 1/3 times 3 is 1. 1/3 times 27 is 9. 1/3 times 3 is 1. So we just multiply all of those by 1/3. That's why it's called scalar multiplication, because a scalar is a single number, so we're multiplying it by that matrix. If it was a matrix times a matrix, it's a much more difficult process. So stick with this here. Okay, and we have to do the same with the other one. This one, we've got to take the 2 in there to all of them, right? It's got to get multiplied by all those. Now you have a couple options. You could just take the regular 2 in there and multiply them all and keep the minus sign here. Or you can multiply everything by -2 and then change that to a plus sign. What you don't want to do is multiply everything by -2 and then subtract. You only want to distribute that negative one time. So I'm just going to keep the negative out there and just multiply everything by 2. So it's -10, 12, -12, 0, -6, and 6. So I just multiplied everything by regular 2. Again, you could multiply everything by -2 and then just add them, but just make sure you don't double up that negative symbol. Okay, then we're gonna, in this one, subtract, so it becomes -5 minus -10, so it becomes +10, which is gonna give me +5. We've got 0 minus 12. 0 minus 12 is -12. 2 minus -12, which is +12, so that's 14. 9 minus 0 is 9. 1 minus -6 becomes 1 plus 6, so that's 7. And 1 minus 6 is -5. This becomes even more challenging to make sure you get them all correct because there is so many chances for error in this. Do your best, though. Take your time. Double check your work. All right, and our answer will be a 3 by 2 matrix, 3 rows, 2 columns, because each of the original matrices was a 3 by 2. So we'll go ahead and type those in. And hope we got them all correct. Very good. Let's do one more together here. Go ahead and clear this out. So I would recommend writing some stuff out when you have these multiple operations. It'll save you time in the long run. So we've got negative a minus 1/5 b. All right, so negative a is going to be negative, and then I'm going to go ahead and write out the matrix A, 6, negative 1, negative 2, and then minus 1/5 b, 45, negative 40, and 20. And all of these delta math problems, even though it looks like you're multiplying by a fraction, you should end up with whole numbers on all of yours. And you can even think of it as just division, because 1/5 times 45 is just like the same thing as saying 45 divided by 5, so it's 9. Right, so all of these should work out. What I'm going to do here, since this has a negative in front, it's sort of like a negative 1, right? So I'm going to go ahead and distribute that into all of these terms and make this negative 6, positive 1, positive 2. And this time maybe I'll switch it up. I'm going to go ahead and distribute this whole thing, negative 1/5 times all of these. So I'm going to write a plus since I'm going to take the negative inside of there. So negative 1/5 times 45 would be negative 9. Negative 1/5 times negative 40 would be positive 8. And negative 1/5 times 20 would be negative 4. So then I've just got to add them together. It may make it easier for some of you if you distribute that negative, then you're just adding. So then we match them up. Negative 6 and negative 9 is negative 15. Add them together. 1 and 8 is 9, and 2 and negative 4 is negative 2. So let's see if I did that one right. First thing we need to do is make sure we get the right dimensions. So I want to subtract a row because it is a 1/3 matrix. Huh, that's unfortunate. I lost everything. Okay. All right, let me go ahead and do that again real quick. Sorry about that. I'm not sure what happened. 2 plus negative 9, 8, and negative 4. All right, so our answer there was negative 15, 9, and negative 2. If I didn't mess one of those up. All right, there we go. Okay, so that's all there is to it. Just make sure you're distributing, being extra careful when you're adding, subtracting, and let me know if you need some help.